Hi everybody, this is Matt Ingram with a quick video on troubleshooting um, incorrectly created spatial weights matrices. Basically this problem came up with Marcelo's project in Brazil. So he was originally looking at a shapefile, a municipal level shapefile in Brazil. This is connected to his research and also to some of the work we've been doing together. But he wanted to replicate the spatial regimes analysis that we looked at in replication 1 in Baller et al. And so he basically created two regions in Brazil. Here what you see depicted in this map is the northern region in green, and then a southern or south central region in lavender or purple. And when he created the two different weights matrices, so one spatial weights matrix for the northern region and a second spatial weights matrix for the southern region, when he created those two different weights matrices in Geoda, it looked like they were created incorrectly, and so we were trying to figure out how to troubleshoot this. So we're going to walk through the steps that led him to discover the problem and then walk through a solution. So basically in Geoda, if we open Geoda, this map on the left that I'm moving right now is the same as the segment or the region, the spatial regime in northern and northeastern Brazil. So you'll see this is only the northern half of the country. I'm just going to make it a little bit larger so we can see what's going on. And basically, as Marcelo looked at this partial shapefile of Brazil, these 2,200 municipalities, he noticed that the municipalities, that the weights matrix did not appear to have captured adjacency or contiguity correctly. So let's see what this looks like. Remember that in Geoda you can click on any given municipality or feature and identify it, right? And if you open the table, you'll see it also identified. If you generate other plots, you'll see them linked together, right? And whatever you do in one plot appears also in the map or in your table. One nice feature of Geoda is that you can click on a polygon, a geometric feature, and if we go up to table and add neighbors to selection, it'll show you how your spatial weights matrix has identified the neighbors of any given unit. So here we see that with this unit that we selected, right, we should see probably 1, 2, 3, and 4 neighbors. All of these different units that are, well, 1, 2, 3, 4, 5 neighbors. We should see probably 5 neighbors. And when we go to table, add neighbors to selection, it's only identifying one neighbor. This is a major problem if we're going to be doing analyses of dependent structures in the data when the dependent structures themselves are not being captured appropriately. So Marcelo continued looking through this and found more examples of this. Probably the worst examples are ones like this unit over here, where if we go to table and add neighbors to selection, nothing happens. Right? So this table, this unit, that is landlocked and surrounded by 1, 2, 3, 4, maybe 5, 6, somewhere between 5 and 7 different neighbors, is being registered by Geoda as an isolate, that is, as having no neighbors. This is plainly incorrect. So one quick solution to this is to move to R, and I'm just going to bring up a R script that helps to solve this problem and walk through it. So you've got a header here with some basic information about what we're trying to do. We've already discussed the nature of the problem and what we're trying to resolve. This package installation and the opening of the packages should be familiar to you now from working in R and doing some of the replications in R. We want to set the working directory. Remember to set this working directory to your own working directory. This is where I have the files, not necessarily where you might have the files that you're working with. So let me just check to see what the current working directory is. Remember that you can highlight any amount of your script and hit Control R to execute. I am not in the right directory, so I'm just going to set the working directory and then check it again. Now I've moved into the right working directory, and here are our files. So here's the northern shapefile and the original weights file that Marcelo created, and the other shapefiles. So let's read first the northern shapefile, the one we were just looking at. Because it has, remember that because if you have a projection file, you should be using the read OGR command just so that it captures that shapefile automatically. And this is the format for that command. You need to provide the file path and then the name of the shapefile without the SHP extension. So let me just execute this here. Load our shapefile. Again, this will be the same. This will be this same shapefile with no spatial weights matrix yet constructed. Just give it a second here. I'll come back as soon as it's done. So here we are back again, and we can see that the shapefile loaded correctly. We could summarize it if we wanted to. And we see here that it summarizes, and again, just some confirmation that it loaded correctly. I'm sorry, we could summarize it here, or load some the names of all the variables. Sorry, to create the data frame, and then check the first 5 observations. We can see that all of the observations loaded correctly, and we could also do just a quick confirmation to make sure that it loaded correctly, or a quick plot to make sure it loaded correctly. All of that looks good. So now let's just construct the spatial weights, and we're going to repeat the same kind of spatial weights from Geoda. So that's a Queen 1 adjacency or contiguity weights matrix. So let's just create this neighbor file, and we could, as soon as it's done, summarize it. So here we are again, and it's done, and we can quickly summarize it. We see that there are no regions here listed with 0 links. That is, there are no isolates in the spatial weights matrix. That's already a very positive signal of an improvement over the weights matrix, the incorrect weights matrix that was being constructed in Geoda. We can move farther down and see that the least connected regions have 1 link here, right? So there's 604 regions with just 1 neighbor. Again, that's a sorry, one least, excuse me, 1 least connected region. That's unit 604 with 1 link. You can see that up here in the link distribution as well. The number of regions with just 1 neighbor is 1. After that, there are almost 40 regions with 2. So really, this is just one more confirmation that there are no isolates. Again, that's a huge improvement and resolution of the problem that we saw in Geoda. We could generate the coordinates of the centroids. Basically, you're capturing the centroids as we do in Geoda of the polygons. We could generate the coordinates of each of these polygons and plot that. So we're plotting the connections among the centroids in this northern Brazilian shapefile. And again, we can see just a visual inspection of this also lets us know that there are no isolates, there are no unconnected regions. So all ways of checking that. So we could plot this against the shapefile as well. We've got the boundaries there, and we're just going to add now the same linear connections, but now in red. So that's what they look like. Again, this looks correct. A nice comparison to do would be to compare these statistics that we see over here of the weights matrix that we generated in R, and compare those statistics with the weights matrix that was created in Geoda, and then also do a visual inspection of the maps just as we did. So let's load the original weights matrix that we created in Geoda and check that here. So we didn't construct it ourselves in Geoda, but here, this is the GAL file, the Queen 1 contiguity weights matrix that Marcelo created and that I also replicated in Geoda. So we're going to load that using this command read.gal, and we're going to create this object, a northeast GAL, out of that weights matrix. This is one nice thing in R, is that you can read Geoda files into R. If we summarize that Geoda weights matrix, we can see right away some problems, right? So here's 300 regions with no links. Again, if we scroll up to the weights matrix that we created in R, there are no links, right? There are absolutely no units with no links, so there are no isolates. We go down to the summary of the Geoda weights matrix, and we see that it somehow created isolates out of the shapefile from Brazil. Here we see again when the link distribution, those units that have 0 links number 300, and that's really a problem. So we can also see that in the average number of links. The average number of links per unit in the R created weights matrix is almost 6. The average number in the Geoda weights matrix is 4.5. Again, much denser connectivity in the weights matrix created in R. So that suggests it's correct. So let's now plot them side by side. We're going to plot this NNE gal, the one that was created in Geoda, against NNE neighbor Q1, which was the one we created in R. So this would be the R. This would be the R, the shapefile, and then this is the weights matrix created in R. And then again, we're going to create a new plot of the shapefile and add the weights matrix created in Geoda. So let's put all of these together and see what the graph looks like. And here I'm just going to enlarge it so that we can look at it closer. In the top are our weights, Queen 1 weights from R. In the bottom are our Queen 1 weights from Geoda. And here you see this is the first unit that we looked at in the map in Geoda. We see that in R it's connected to all of its neighbors. This is that same unit, and you see that in Geoda it was connected only to the neighbor to its east, right? Which is what we saw visually when we first looked at the shapefile in Geoda. So again, we've looked at the summary statistics, the numeric statistics, but this is a nice way to visualize the comparison between the two weights matrices. So now we could export that graph as well using this command and then the closing command. So let's do that. And then we would have that graph available to us outside of R as a portable networks graphic file, as a PNG file. So one last check we could do just to see if this top weights matrix in R is symmetric, is to make the weights matrix symmetric. So let's do that and then look at the summary statistics. We see that it's basically the same 5.86 is the same as the weights matrix that we had created earlier. We could then turn this into a list object if it were different, and we could compare the two side by side if we wanted to. This is the first weights matrix we created. We see that the average number of links is 5.863. This is the symmetric list, and it's also 5.863, so they're virtually the same. So from the beginning, R created a symmetric queen 1 contiguity weights matrix. This is a nice solution to a problem of incorrectly constructed weights matrices. So if you ever find yourself in the situation in which Marcelo found himself, where you locate a shapefile from elsewhere, maybe it's a government or non-governmental source, you start doing your analysis, you construct some spatial weights, and you notice some problems in it. Maybe it's not capturing all of the neighbors correctly. You can generate the weights matrices in R and then check to see that the corrections were done. So obviously this is not a problem with the original shapefile. It appears to be some problem with how Geoda was constructing the spatial weights matrix. It's nice to have a solution when you encounter those problems. Just as one last step, we'll look at that PNG file that we exported, and so here it is. You could copy and paste this into a report or a Word document or a LaTeX file if you wanted, and this is really portable for a wide range of formats. So that's it. That's our solution for this problem of incorrectly specified weights matrices. Thank you.